Hey everybody, welcome to another YouTube video, second one of 2020. In this video I want to go over the plans of TurboDirect for 2020 and some of the exciting performance bolt-on upgrade turbochargers that you can expect coming out of our stable. What we want to do is approach the following vehicle brands: VW, Audi or the VAG group, BMW, Merc, Ford, Toyota, Isuzu and Mazda. Obviously, because of the Isuzu, Mazda and Ford, you can obviously assume and you can guess what types of vehicles we're going to be approaching, obviously the Toyota as well. What we basically wanted to do is go over our capabilities. What are we actually capable of? What sort of experience do we actually have to be able to design our own in-house bolt-on rotating assembly, which will utilize the old OEM end housings on a specific turbocharger for a specific engine model. Now, because we've been a master distributor for Garrett and currently are also for Borg Warner and Mitsubishi and IHI for over 20 years, we have had extensive exposure to the product, from the marketing perspective to the technical perspective to the failure perspective. We've got our own metallurgical forensics in-house, which can go down to an analysis of micro and macro structure should it be. We've been actually hired by one of the OEM manufacturers and actually paid by them to do a forensic analysis on a turbocharger failure on a specific engine. So we have a very strong metallurgical and a very strong engineering background. So, you know, of those cornerstones and that strong foundation, we believe that we are very, very capable of designing our own rotating assembly. And obviously we won't recreate the wheel as we'll go into just now. Some accolades and some achievements over the years. In 2009, I designed the very first billet compressor which came out of our stable, called the KO4R. That is the billet compressor which we have over here, and that is a 6-blade splitter. It is specifically designed to upgrade your KO4-64 turbocharger, which comes out as standard on the Audi S3, the TFSI engine from 2008-2010. And those are obviously utilized to upgrade as a bolt-on the Golf 5 and the Golf 6 GTI and TSI engines. So that was our very first attempt. If you have a look at companies like KTS in Malaysia and some of the other remanufacturers of compressor wheels in China, etc., you will find the dimensions of our exact KO4R billet compressor inside of their catalogs. Everybody's copied it. So we went and redesigned that into a 7-blade splitter design, which is basically the same identical dimensions in certain areas to the 6-blade, and we've basically gone and increased the flow capacity from 40 pounds per minute of airflow to 44.5 pounds per minute of airflow, and obviously those that know how to read a compressor map can equate that to 450 horsepower. So in 2012 we also exhibited at SEMA, and we exhibited these billet compressors as well as our own in-house design turbine housing, stainless steel turbine housings, which obviously went up against one of the well-known brands, and it has a number of features that are better than the existing offering, or at that time better than the existing offering was. So we have got proven, race-proven products in the industry, both locally and internationally, where we actually have these products running reliably and making the horsepower that they were designed to make. So what we've basically gone and done now is we've gone and targeted very specific applications, which I'm going to talk to you about in the South African markets. Now, over the last 2 to 3 years, there's been a number of companies locally who have tried to build a hybrid upgrade for specific engines. And that specific engine has found nothing but reliability problems in terms of the turbocharger. Now, when you design a billet compressor, you design the wheel as an upgrade to the standard unit, and you have a horsepower target in mind. Now, horsepower, for those of you that have watched my other videos on compressor map plotting and understanding how compressor maps work and the spec sheet of a compressor wheel, you will understand that in order to achieve a certain horsepower, you need a certain flow rate. Now that's a three-dimensional map, so you'll have flow versus pressure, what boost pressure, and you'll have a speed rating in relation to basically give you a specific flow at a certain boost pressure, at a certain rotational speed. Make sure that the rotational speed won't burst the compressor, so your route design needs to be correct. You need to make sure that the bearing system, especially if it's journal bearing, which 99% of the standard OEM cars of today are, will not fail because you've oversized the compressor and you've changed the relationship between the actual turbine and compressor to something that is completely and totally, utterly oversized like that. Now, what that basically does, and I'm going to just do this very, very briefly, is the thrust coefficient or the thrust loading of the compressor versus the turbine in this specific match, which you can obviously see a clear, huge overpowering difference from the compressor stage, is you will overpower the thrust assembly. You will eventually land up having end float, blades will touch housing, sometimes turn shafts off, unreliable. Now, the reason this has happened in our industry is because the horsepower rating of the billet compressors that are coupled together with turbines are, let's say for example, rated at 500 horsepower. In order to achieve 500 horsepower out of that blade, you will need to boost 2.5, 2.2, 2.4 bar round about there. But the bearing system is only capable reliably of handling 1.5 to 1.6 bar. Now you go and upgrade the rotating assembly diameter, totally throwing off the thrust loading ability of the thrust bearing inside of that turbocharger, and you have a turbo that lasts 2 weeks, 2 months, 4 months, whatever the case is, but it is totally unreliable. So we've now sat back, received emails, inquiries, phone calls from the local tuners, fabricators, etc., and said, listen guys, do you have a hybrid turbocharger for this vehicle or for that vehicle? And we've said, yes, we do. What is the horsepower target? No, 500, 550. The horsepower target is high. So our natural response was, use a ball bearing Garrett, use a ball bearing EFR, use an Airworks, use a turbocharger specifically designed for performance. Fabricate an adapter or a manifold or whatever the case might be, and you have a reliable setup. Now, the issue is, the clients want a bolt-on setup where no fabrication or very little fabrication is required in terms of downpipe, oil feed lines, water feed lines, etc. And obviously an adaptation to an intercooler pipe, but purely bolt-on is essentially the source for the upgrades at the moment. For 500, 550, 600 horsepower, you're going to need to run a ball bearing rotating assembly. One of the advantages of running ball bearing are because a ball bearing rotating assembly can handle 50 to 100 times the thrust of a normal journal bearing thrust assembly. Now, we've gone through the years of being involved directly with Garrett, Borg Warner, IHI, Mitsubishi, etc., and that's more than 20 years. We've been involved from the marketing of the product, to the selling of the product, to the failure analysis of the product, training received abroad on more than 5 occasions in many different countries. We have a metallurgical and forensics department which can write a report and go and do an analysis on any material right down to micro and macro structure. In actual fact, we've been paid by one of the OEM manufacturers to go and do a failure analysis on one of the turbochargers from a specific vehicle brand. Shortly thereafter, they retooled and renamed the part number on that specific turbocharger. So we have what it takes to be able to design, analyze, and understand exactly what turbochargers are, how they work, how they live, how they die, and make sure that whatever rotating assembly we put together will remain reliable under the operating conditions of the intended design. So we've now come up with a ball bearing cartridge, which is the original cartridge which you will find in the OEM turbochargers that you can find in the market today. We use exactly the same ball bearing cartridge, but we have redesigned our own billet bearing housing and bearing housing backplate combination to fit as a bolt-on upgrade for various vehicle brands, like we've just discussed, the VWs, BMWs, Mercs, Toyotas, etc., etc. So that is essentially the gist of what we're basically doing. I will show you other videos now of the drawings, just a brief intro onto the actual design of the bearing housing that we've gone and created. We have already machined the first prototype. and we are going to assemble. We've already got our own turbine design, our own billet compressor wheel, which obviously is proven in the industry already. We've got a number of vehicles, including bikes that hold records using our own billet compressors, as well as turbochargers that we've pieced together and custom built for certain companies and certain races. So we want to basically go through these components, assemble a rotating assembly, do destructive testing, see if it's market worthy over the next couple of weeks. Once we have got a thumbs up and proofed the product, we will release that into the market. So stay tuned. Keep an eye out on our Facebook page and all of the other social media, as well as our YouTube channel. If you want to be notified of new videos and new developments, click on the subscribe button, click on the bell, and off you go. Let's move on to some of the other videos now, and I will show you some of the designs of the turbine wheel and compressor wheel combination. I'm actually going to go and put them next to genuine Garrett rotating assemblies and weigh them to show you where we are going with the ideas that we have. And at the same time, after that, we'll come back and we'll close the video off. Hey guys, this is a quick intro to show you guys that we have a new billet bearing housing and backplate design, which we have designed specifically as a bolt-on application for some of the popular turbochargers out there. I'm not going to reveal what this is just yet. Just stay tuned. We'll obviously keep you guys updated as to what vehicle and what make and model turbocharger this is for. But to give you an idea, this is our billet backplate and bearing housing design, specifically utilizing the ball bearing, the OEM genuine ball bearing cartridge from the manufacturers like Garrett and Borg, etc., etc. So this is a specific unit which will replace the rotating assembly only inside of a very popular passenger vehicle turbocharger, and we will couple this together with our own design turbine and billet compressor wheel. Stay tuned, keep watching and keep looking back at our social media pages and obviously YouTube, etc. We will release the launch date of this specific unit soon. So this specific bearing housing will keep or maintain the oil in, oil out, water in, water out fittings that are used on this specific OEM bolt-on application. However, it will be basically upgrading the rotating assembly to a dual ball bearing setup. So you'll be able to boost your 2.5, 3 bar boost, whatever boost pressure you want to run. In combination with our rotating assembly, we're looking for a 650 to 700 horsepower capable application over here. It's a 4-cylinder engine. It's in the 2-liter 16 valve category. It'll have V-band connections that attach bearing housing to turbine housing, but you will utilize the standard OEM end housings, actuators, etc. However, the rotating assembly itself will be a dual ball bearing, higher horsepower capable setup. Coming soon. Stay tuned. We will update everybody via the necessary platforms as to the launch date of this. It's quite an exciting project. I hope you guys like it. Hey guys, this is the second design billet bearing housing, which we're manufacturing specifically for a bolt-on application for one of the very popular OEM vehicles that are currently in the market. This is basically going to be a billet ball bearing housing, utilizing the dual ball bearing cartridge from the OEMs, like for example Garrett and Borg. So this basically will allow us to upgrade the rotating assembly inside of this OEM turbocharger to a ball bearing rotating assembly. All of these designs are made and drawn by us at TurboDirect, and the billet compressor wheels are designed, drawn and manufactured by us in-house, and we will basically be doing all of the manufacturing of these components in-house for various reasons. And these are basically going to be taking the bolt-on turbochargers to the next level. You will basically still have your OEM oil in and out, water in and out. The only thing that's going to be different is we will be changing the rotating assembly, the bearing housing, the ball bearing cartridge inside, and obviously the billet compressor wheel and turbine combination, which will then obviously pick this specific turbo up to an 850 to 900 horsepower capable setup. This is a twin turbo application, so we will be releasing more detail as to what vehicle and what engine and what power plant this thing fits in the coming weeks. Stay tuned, check out our social media pages and YouTube channel. If you haven't subscribed already, do so. Click on the bell. As soon as we do upload new videos, you guys will be notified thereof. We'll be updating some manufacturing videos as well, so that you guys can actually see these components being machined on our own in-house CNC machine. We've got about 4 or 5 of them now, but I hope you guys enjoy this. Stay tuned for some more exciting news on these bolt-on ball bearing upgrades. Hey everybody, okay, we're back here. Just wanted to show you guys a little bit about the turbine design and billet compressor combination that we've been working on. I spoke to you briefly about the 2 different sizes in inverted commas GT30 and GT35 size dimension families, which we're busy working on. Here's an example of where we're going with this. This is a Garrett, genuine Garrett GTX 30 turbine wheel, which measures inducer 60 millimeters and 55 on the X juicer, and on a scale it weighs about 241 grams. This specific unit here, I'm not going to show you the blade design just yet, is a 70 inducer and a 64 X juicer blade. So it operates in the GTX or GT35 family in inverted commas. And the weight is approximately 20% less than the smaller turbine. Now, if we take into account this is a billet compressor designed by TurboDirect and manufactured by us, it is not a copy of a Garrett. It is nothing to do with the Garrett design at all, nor is this Hulk wheel over here. It's one of our own in-house designed and manufactured products. Inducer, X-juicer, tip heights, the sweeps, the lofts, everything about these blades are totally different to the Garrett product. And if you combine these together, the total rotating assembly of a Garrett combination, for example, 352 grams, as opposed to 336, so 337. So it's quite a substantial difference between these blades, purely based on the fact that this is a much larger rotating assembly than that. This X juicer here is 86 millimeters, the end juicer is approximately 67, and as opposed to a 78 and a 60. So it is a substantially larger rotating assembly, and it weighs quite a bit less. If you look at it a couple of grams, but understand something, you're talking about a much larger rotating assembly. So response, together with the ball bearing setup that we're going to be using, is going to obviously be critical, and that's where you're going to see massive gains. So more info coming. Stay tuned. We'll reveal the rest shortly. Hey guys, welcome back. So I hope you liked what we've just shown you there. I hope you guys are excited as we are. Remember, subscribe, like, comment down below, interact with us. We want to hear what you guys have to say. And hope you guys enjoyed that. See you guys next time. Cheers.